Okay, so what I told you last week was to identify asymptotes without doing any form of working, by just looking, okay, you should be able to tell the vertical asymptotes and the horizontal asymptotes. Okay, so like, for instance, let's say if I give you this. What is the horizontal asymptote?
Wait, I forgot. Crap.
Okay, that's why this is the whole purpose of refresher. Okay, whenever, okay, if you don't remember and you want to remember, right, let's say like tomorrow is your test. Okay, you want to remember, right? The video, did I send you the video link?
I don't think so.
Oh, I didn't send you the video link then.
Oh, is it the
I did. Yeah, I sent you a oh, I didn't send you a link. Okay, wait, hold on. Let me send you. Okay, I send you first. So you will save it under your WhatsApp. So when next time you want to watch your asymptotes and logarithm lesson, you can just come to this page.
Oh, okay.
Yeah. Okay. So coming back to this. Okay, doesn't matter. Now I will help you to do the refresher. Okay. So whenever, okay, so this is in the form of fx over gx, okay? Like fx, y is equals to fx over gx, right? Okay, whenever if the order of fx, if it's smaller than gx, the highest order, I'm talking about the highest order, okay? Okay, if the highest order of fx is smaller than the highest order of gx, okay, in this case, this is 6, right? This is
20.
20, yes. So if the order is smaller, the horizontal asymptote will be y equals to 0, 100%.
Oh, yeah.
Okay, remember this? So next, if let's say I have y equals to 32x to the power of 8 plus 3x to the power of 5 over 15x to the power of 5 plus say 4x to the power of 8. Okay, so this is when my fx, the highest degree of my fx equals to the highest degree of my gx. Correct? Because what's the highest degree here in the numerator? 8. What's the highest degree in the denominator? 8 as well. Correct.
Yeah.
So if the highest degree in the numerator and denominator tallies, right? So straight away you can just look at the coefficient of the highest degree, which is 32 and 4, right?
Yeah.
Yeah. So your horizontal asymptote will be y is equals to 32 divided by 4.
Oh, okay.
Which is equals to 8 lah.
Okay.
Okay. Lastly, okay, what happens if my fx is greater than gx? Okay, if fx is greater than gx, okay, there's a restriction to this. The restriction is that it can only be 1 degree higher. How many degrees higher?
1.
1. Okay, only 1 degree higher. So an example will be like, for instance, 2x squared plus 3x minus 1 over x plus 2. Highest degree 2. Highest degree 1. Right? Sorry.
Yeah.
Yeah. So since you know that the highest degree is only 1 degree higher, over here for this we cannot tell visually. For this we cannot tell visually. This one we have to do something. What is that something?
Long division.
Correct. Okay, so let's say now we execute the long division together. Okay, so we have 2x squared plus 3x minus 1. Then we have x plus 2. So we get 2x. So we get 2x squared plus 4x. Correct me if I do anything wrong. I mean, I'll make mistakes also. 3 minus 4x is minus x minus 1. So over here I have minus 1. Yeah. So I have minus x minus 2. So here I have 1. Because 1 minus 1 minus minus 2 means minus 1 plus 2, which is 2 minus 1, which is 1. Right? Okay. So from here, we're going to translate this. Okay. So 2x squared plus 3x minus 1 over x plus 2 will be equals to quotient plus remainder over divisor. Okay?
Yeah.
So where is the asymptote? Okay? Where do you think is the asymptote?
1 over x plus 2.
What kind of asymptote is that?
Y equals 0?
No. Okay? So when it's 1 degree higher, right? When it's 1 degree higher, okay, it will only have vertical asymptote, maybe, we're not sure. But for sure, there will be oblique asymptote. Okay? There will not be horizontal asymptote. There will not be.
Oh, okay.
Okay? There will not be oblique asymptote. But there will be, maybe there will be a vertical asymptote, and 100% there will be oblique asymptote. Where's the oblique asymptote? Oblique asymptote means what? It is a slanted line. It's a slanted line. And back then in Sec 3 and Sec 4, A Math and E Math, we learned that any slanted line will have a linear equation of y equals to m
X
plus c, correct? So which term in this expression shows us that we have a linear equation?
Or 2x minus 1.
Yes. So the 2x minus 1 is the quotient of the long division. It is also the equation of the oblique asymptote. Can?
Yeah.
So right over here, right, what we can extract from this rational term, right, is the x plus 2. Because we know that from x plus 2, right, we can confidently conclude that, oh, there's a vertical asymptote of what? X equals to?
Minus 2.
Minus 2. Perfect. Okay?
Yeah.
Okay, ma? Yeah, what, okay, but over here, why did I say that? Okay, maybe there will be vertical asymptote. Why? Because let's say, for instance, if let's say after I do my long division, then I get 2x minus 1 plus 1 over x squared plus 2. Let's say, for instance, then you'll be like, okay, I want to find vertical asymptote. So x squared plus 2 equals to 0, x squared equals to minus 2, then you'll be stuck. We went through this example previously. Then you have NA. Oh my god. What am I writing? Then you have NA, right? Or reject.
Yeah.
Cannot. That's why maybe there will be vertical asymptote. It's not 100% we'll have. Yeah. Can? Okay.
Wait, then how do you find the vertical asymptote again?
For which one?
Like I forgot.
Yeah, sure. Vertical asymptote, you always equate the denominator, which is okay over here, this gx, right? At the top, on the top left.
Yeah.
Okay. Look at the gx. You always equate the gx to be 0.
Oh, okay.
Yeah.
Okay.
Meanwhile, what I can do is, let me send you the cheat sheet. Anyway, this thing will be recorded, so you can still refer to it. I haven't got time to do like more cheat sheets for y'all recently, cause like I have to do online lesson. Yeah. Graph transformation. Should be graph. Is it graph transformation? It's not this. Oh, shit, it's not. Sorry, I'm trying to find a cheat sheet for
Yeah, okay.
Where did I
Sure.
save it? Summation. Curve sketching. Yes, I found it. Okay. Okay, you can open up the document, right? So when you open up the document, right,
Yeah.
you should see the cheat sheet.
Oh, okay.
Yeah. In a case, how to find vertical, how to find horizontal, how to find oblique. You have case 1, case 2, case 3, everything is labeled there. The bottom part you can ignore. I don't think you will need it now, but maybe eventually, yes.
Wait, so what happens when like your numerator has a higher power than your denominator?
Like way higher, right?
Yeah.
If it's way higher, then usually it's not in the syllabus really.
Oh, okay.
Yeah, so don't worry about that. They will not test that.
Okay.
Can Okay, so for logarithms, I think so you can move on to logarithms. For logarithms, I don't think you have any big issue. I just want to maybe go through a few questions first. A few questions on logarithms before we move on to the exponential and or decay model or something like that.
Okay.
Yeah. Yeah, answer all your queries already regarding the.
Yeah.
Yeah, great. You have any like questions you want to ask me first before any questions from school?
No, because today we finished logarithms.
Logarithms.
Yeah.
Oh, okay. Means should not be a problem for logarithms. Then we don't have to do questions on logarithms. We just go to the decay one.
Yeah, because like I think I'm okay with the school practices.
Okay, and your school practice stuff is definitely not easy. I mean,
I think so.
okay. Previously we did example on the expo on the compound interest question. Remember?
Oh wait, do you have like practice questions on factorial?
Factorial, you mean P and C?
P and C.
You mean like permutations and combinations? Is it? What do you mean by factorial?
As in like the n factorial thing.
Which is
Binomial.
oh, it's binomial lah. Not you're talking about binomial, right? Because factorial is present in two topics. One is in permutations and combinations. The other one is binomial.
Yeah, binomial.
Binomial.
Yeah.
Okay. You you already ended that that topic, right?
Yeah, that was quite some time ago, but I just remembered that I had a bit of trouble with factorial.
With binomial lah.
Yeah.
Okay.
Binomial factorial function.
Shall we rectify that first?
Yeah.
Okay. Let me share this with you. Okay. Okay, expansion of binomial theorem should not be a problem, right?
Yeah, sure.
Like when you want to expand, you should know this formula, right? Okay, I think maybe that one too confusing. It's like basically, let me do it. Sorry. Okay. So for example, if I have like a plus b to the power of n, okay. So my first term will be when I want to expand the binomial, this binomial term, right? It will be n choose 0, a to the power of n, b to the power of 0, which is 1. Okay, plus n choose 1, b a to the power of n minus 1, b 1. Okay, plus n choose 2, a to the power of n minus 2, b 2. Okay, so on and so forth until you get n minus 1, a 2, sorry, a1, b n minus 1 plus n choose n, a0, bn. Okay, you know of this expansion, right? Okay, very good. So for n choose, there are a few terms here you need to know, which is that n choose 0 is always
And
1. Okay? N choose 0 is always 1. Because why? Think about it. Let's say now you're in paper 1, then you don't know, right? Imagine you got 5 pencils. Okay? How many ways to choose 0 pencil? Okay? This is 5 choose 0, right? You got 5 pencils, you want to choose 0 pencils. How many ways to choose 0 pencils? There's only one way. That one way is to not choose.
yeah.
Yeah, correct, right? Yeah. So this is one important property. The other important property is n choose 1. So imagine you got 5 pencils. How many ways to choose 1 pencil?
5.
5, which is n over here.
Yeah.
Yeah. So let's say you have 5 pencils. Now you want to choose 5 pencils. You got 5 pencils. You want to choose 5 pencils.
5.
Sorry? I can't hear you.
5.
There's only one way. You have 5 pencils. You want to choose 5 pencils. The only way is to choose all.
Oh.
Make sense?
Yeah.
Yeah. So all these are very important properties of binomial expansion or factorial. Okay. So let's say if you don't remember this, is there a formula for you to know or remember or memorize? Yes, there is. N choose r is equals to n factorial over r factorial times n minus r factorial. This should be in your formula booklet.
Yeah.
So that one not to worry. Okay? Can?
Okay.
Okay. If all is good, then maybe we can try one question. Because I don't know what you know or what you don't know.
Yeah, it's the more difficult questions that I get a bit confused with the extension. Yeah.
Okay, can you show me on a paper how you find A, part A?
Sorry, do you have the general formula?
Sorry again?
Like the formula for general formula, I forgot.
You mean okay. That one will be in your formula booklet, but it will not be so obvious because what they will do is they will show you the whole chunk. Okay, so you have the TR plus 1. They will not show you this. They will show you like in the middle of the expansion in a formula booklet, which is n choose R, A, n minus R, BR.
Okay, thank you.
Welcome.
Okay, I sent you.
Okay. Okay. So over here we have choose R. We have 2 9 minus R x squared times of wow, very good. Minus 9. Isolate the x terms. Good. Good. Correct. Okay. Let's move on. There is any question.
No, as in like, you know those questions where they, hang on,
Maybe you can show me.
saying, I'm looking at like the O-level stuff, but there was this one part where it was confusing. Like example 8. Oh yeah, and example 7. Okay, I'll send you finish example 7.
Wow. Find a simplified expression in terms of n.
No, that's not the full part. Hang on.
Okay,
I'll send the full page.
sure.
Yeah. 7 and 8. I think I need like a recap because I forgot how to do.
I swear, right, the current SL students will see this, right? They will shit in their pants.
I got very confused. I don't think my class understood, but she just moved on. Then we were like, okay.
Find a simplified version in terms of n for the coefficient of x in the expansion of okay. Means we need to expand this.
Yeah, to find the coefficient of x.
Oh, this is madness in a house. Never expect this kind of question to be in binomial. 1 plus 4x. It's just 1 plus 4x, right?
But I don't understand what they mean by as in like coefficient of x1.
They want the coefficient. They want, sorry, find a simple coefficient. I think they want you to find a general term. A general, yeah, the word is general term.
Oh, okay.
Like a formula, okay, general term or a formula or an equation, a general term or equation or formula for the coefficient of x. Means it's x to the power of 1.
Yeah.
You just want that one term only. Okay, so over here, the for this one we have 4x, right? Then for 1 plus 4x to the power of 2, we will have is it written there? We will have 1 plus 8x plus 16x squared. Then for 1 plus 4x cubed, okay, we will have 1331. So it's wow. We will have 3 choose 0, which is 1 to the power of 3, which is just 1. Which is just 1. Right? Plus the second one is 3 choose 1 to the power of 2, then we have 4x plus 3 choose 2 1 to the power of 1 4x squared. Actually, we can just stop here already because what we want is the 4x, right? So over here we have 1 plus 3 choose 1 is 3. 3 times 4x is 12x. Okay. So from here, we more or less can see a pattern, which is like 4x, 8x, 12x, oops. You know, the fourth term will be 16x, then so on and so forth. 20x, right? Yeah. So over here we to see the pattern, because we need to know what is the n term over here. Okay. We know that from here to here the common difference is 4x. 4x. Right?
Yeah.
Yeah. So what we want to find, have you learned APGP yet? Arithmetic progression and
Yeah.
so you know that to find the UN, this is the AP, so it'll be the first term plus n minus 1 d. Okay, so our first term is 4x plus n minus 1, d will be 4x.
Oh, it's APGP.
Then from here we will have oh no, sorry. We are supposed to find the sum. My bad. I made a mistake. We're not supposed to find term. We're supposed to find sum. Because we are supposed to add everything up here together. We're supposed to add all the 4x, 8x, 12x. We're supposed to add them all together because of the equation here.
Okay.
Yeah, right. So it's a Sn for GP. It's the sum of the first n terms. So it'll be n over 2 u1 plus un. First term plus last term, right? So the first term is 4x. The last term will be it's un, so it's still 4x plus n minus 1. D is 4x as well.
4x. Yeah.
Yeah. So from here, you just have to simplify it.
Oh, okay.
Yeah.
Oh, that makes sense. Okay. Then
how did your teacher explain this?
Oh, it was super confusing because like she explained, like not explain. She did a whole chunk.
Okay.
I don't think we really understood that, so we're just moving on, so we just accepted it.
Okay. But if you cannot accept it in class, you can come and find me. I will help you to accept it. Okay.
I also need question example 6.
Yes, the next one. On the same page that you sent me, right?
Wait, let me check if I got that in. Yeah, I did.
Yes, you
example.
did. Yes, you did. Okay. It's good that you asked me. We clarify things that you don't know in school first before we start on anything in our lesson.
Yeah.
Maybe if later you don't understand or anything, because I got this recorded already, then you can review it.
Okay.
So the future Anissa can save some time.
Yeah.
Okay. For both part 1 and part 2?
No, I just need part 2.
Part 2, okay. Let's take a look at this. Find the sum of the coefficients. Find the sum of the coefficients in the expansion of this. Sum of the coefficients. Wow. Is this an SL paper?
Yeah.
Currently I have a HL student also from ACSI. This one feels like a HL paper. Oh my god.
Oh no, wait. For question 7, they wanted it in terms of n.
Yeah, you are supposed to have it in terms of x. You will have it for question 7, right?
Yeah.
Yeah, you will have it in terms of x.
No, they wanted it in terms of n.
Oh, in terms of n. Sorry, wait.
Yeah.
I need to see the question again. Okay. So sorry, give me a minute. In terms of n, coefficient of x in terms of n, yeah, you will get in terms of n, because when you add all of them up together, this is the coefficient, right?
Oh.
Yeah, because you're finding all the x term, all the x to the power of 1 term.
Okay.
Yeah.
Okay,
You get it, right?
Yeah, I get it.
Yeah. Okay. Hold on, let me process this question. Sum of the coefficients in the expansion. So you found the coefficient of x to the power of 5. It's not possible for you to find all the coefficients, what? You go crazy. Sum of the coefficients. Unless it follows a specific pattern. If it doesn't follow a specific pattern, GDC required. How did your school do this? I'm very confused about this also.
What is on the screen? Like, that's what my teacher did.
Three, 7, 6, 9. When x or means there's an alternative method.
Yeah. I don't know, man.
This is an exposure kind of question. It's not the technique kind of question. It's like if you never seen this kind of question before, right? If you see this for the first time during IB exam, right, you won't be able to solve it. You have to this kind of question is like you have to recognize that this is how you do it. So when it happens again, then this is how you do it. Because I think it's a GDC question. Is your GDC able to expand this thing out? No, right?
Let me check. What am I supposed to use to expand that out? Just like calculator.
Yeah. Wow, yo. I know already, I know already. I know already. Oh my god. I know already. I think the first way is definitely it's definitely something that you would want to use. Okay. The first way, right? Method 1. Okay, what they did here, right, for your school's method 1, right, is that okay, they really expand this thing.
Yeah.
They really expand this thing. Okay. Then they have like 1 minus x. So from what I can see here is that they have like 2. So the first term is 10 choose 0. Oops. 10 choose 0 2 to the power of 2 to the power of 10 plus x to the power of 0. Then after which we have this one might as well though, because this is still sum of coefficients, right? Yeah, this is still sum of coefficients. Plus means they are doing it manually. They are doing it manually. Method 1 is to do it manually. Okay. Method 2 is better. Okay, what do I mean? We talk about method 2. Method 1 is crazy. We will not do method 1. Okay.
Yeah.
So if this setup comes out again, find the sum of all the coefficients in the expansion. Okay. So basically now I will use a very simple like something like that. Okay, order 2x plus 3 square. Okay. So how do you expand this?
2x times 2x plus 3 plus 3 multiplied to 2x plus 3.
Yes. So you get 4x squared plus 12x plus 9.
Yeah.
Okay. So when we want to add all the coefficient up, it's just 4 plus 12 plus 9, right? Make sense?
Yeah.
Yeah. How are we going to do that? How are we going? Is there a way, right, where we can do that without like expanding this thing to get 4 plus 12 plus 9? What is 4 plus 12 plus 9?
25.
25. Very good, very good. Okay. So to get 4 plus 12 plus 9, right, what I need to do is just to substitute my x equals to 1.
Yeah.
Make sense?
Yeah.
Yeah. So which means this x here, we also substitute as x equals to 1. When we substitute x equals 1, you get 2 plus 3 squared. What do we get?
Say what?
When you substitute x equals to 1, right, you will get 2 plus 3 squared.
Yeah.
What is
25.
25 as well?
Yeah.
Yeah. So when you want to find the summation of all the coefficients in this, you just have to replace your x as
1.
1. Your x as
Oh.
1. That's why they got 0. Because by replacing all your x with 1, you think about the very long chain polynomial. Let's say, for instance, you have like 99x to the power of 10 plus 87 x to the power of 8 minus 68 x to the power of 2, so on and so forth.
Yeah.
If you replace all your x with 1, because 1 to the power of anything is just 1, then what you're left with is just the coefficient. So just remember, when they can rephrase this question in another way, but whenever they ask for the coefficients, just replace all your x with 1, substitute all your x with 1.
Oh, okay.
Very, very smart move. I mean, I take my hats off your school teachers.
Okay.
I didn't thought of that also. But wow, this is a learning opportunity for me.
This is easy.
Yeah, thanks for introducing this question to me. Yeah, but don't do method one. Method one will drive you crazy.
Yeah, that's true.
Before you know it, they say pens down already.
Yeah.
So method one, yeah.
So yeah, continue.
No, I just wanted to say method one is the best way to self-destruct.
That's true.
Okay, question 8 is it?
Yeah.
Okay. Let's see. The coefficient of x squared in the expansion of this is this. Okay. The coefficient in the expansion of, so 3 plus 2x to the power of n. We know that TR plus 1 is equals to n choose R, A, n minus R, BR. So with that said, which means that we have n choose R, 2x, 3, n minus R, 2, R, x, R. So if we want the R to be 2, so it will be T3 will be equals to n choose 2, 3, n minus 2, 2 to the power of 2 is 4, x squared. So we need to find what is n, given that n choose 2, 3n minus 2 times 4 is equals to 20412. So, and we know that, okay, so over here, sorry, MRP. Okay, so we have n choose 2, 3n minus 2 equals to, what's 20412 divided by 4? 5103.
Yeah.
Okay. So from here, because we got n choose 2, this is not a very favorable expression. So we want to change it to n factorial over 2 factorial times n minus 2 factorial. 3n minus 2 equals to 5103.
Yeah.
So said likewise, this expression here is still not very favorable because we have the exclamation mark. No?
Yeah.
We have the exclamation mark. So what should we do is that we need to further simplify it. Because we know that n factorial is equals to n times n minus 1 times n minus 2, so on and so forth, until 2 times 1,
Yeah.
right? N minus 2 factorial is basically equals to n minus 2 times n minus 3 times all the way to times 2 times 1.
Yeah.
So over here what we can see is that when n factorial divided by n minus 2 factorial, this whole part is gone.
Yeah.
So we are only left with n times n minus 1 over 2 times 3n minus 2 equals to 5103. So when I face this kind of very complicated expressions, right? And I want to solve for this, right? You have to use the GDC to plot the graph. You understand what I mean? Yeah, you have to use the GDC to plot the graph. So what you can do is, I will plot the graph of n times n minus 1 over 2 times 3n to the power minus 2 minus 5103 equals to 0. I will plot this graph. Then I find the x-intercepts. So far you following, right?
Oh, then that's n already, is it?
Yes.
Okay. Oh, okay. I get it.
Right?
Yeah.
Yeah. Usually I will bring everything over to the left-hand side. I will let the right-hand side be 0. So that it's easier for me to find the roots than the points of intersection. Point of intersection usually quite hard to spot. Okay?
Yeah.
Okay, we can move on. Any other questions?
No, I don't think so.
Okay. Okay, so we are done with this. Logarithmic functions. Okay. .1. Okay, let's start from the beginning. Exponential functions. Okay, you know how to draw a graph for exponential functions? Okay, now we try some questions first.
As in, yeah, I know the shape, but my teacher told me to use GDC.
Oh, your teacher told you to use GDC?
Yeah, like we drew in class, then she was like, use GDC.
But what if it's paper 1?
Oh, then she taught us the shape, like 伤脑筋. Then you have like the
伤脑筋?
like you know, like the cartoon, then they have like when like you 头痛 or something.
Okay, never mind. Are you sending me something or what?
Oh no, it's not fine. Yeah, she just said plot, like find the asymptotes and like the intercepts.
Again?
She said like remember the 伤脑筋 thing, then like it's either one way or the other. Then she's like, in order to know which way it is, you plot the asymptotes plus the intercepts. Then you know what kind of shape you get.
Not the asymptotes,
Yeah.
intercept, so you know what kind of shape. Okay, never mind. Now I teach you. Don't need 伤脑筋.
Okay.
Sorry, I changed color. Okay, check this out. For whatever graph, right, for whatever exponential graph, right, a to the power of x, okay, a to the power of x, considering that this is just like it can be a to the power of x, it can be a to the power of 2x, it can be a to the power of, okay, or rather, I mean, kx, okay, where k is greater than 0. Okay? Yeah. And a is a constant. Okay, two requirements are. First requirement is k is 0. Second requirement is a is a constant.
Yeah.
As long as you have these, okay, and a is a positive constant, sorry. A is a positive constant. As long as you have these, your graph will look like that. Wow, damn nice, the graph. I did it. It's not easy, trust me. Next time I should bring this thing and let you try.
Nice.
Yeah. So over here, I'm very proud of my graph. I'm glad this is recorded. So this intercept, right? Okay. Once this is true, right? Once this is true and this is true, right? This intercept will always be 1. Always. Okay. Can you hear me? Yeah. It will always be 1. So what happens if k is lesser than 0? Okay. If k is lesser than 0 means, for example, right? Okay, let's say for instance 2 to the power of minus 3x, something like that. Okay. Can? Yeah. So for instance, this example here, sorry, I use a different color. This example here will be 2 to the power of 3x. So if I have 2 to the power of minus 3x, the graph will look like that. Oh shit. But you get it lah, you get it. You understand, right? Yeah. So what's the difference? What's the difference between 2 to the power of 3x and 2 to the power of minus 3x? The difference is that they will reflect about the y-axis. That's all. Okay?
Okay.
Yeah. So there is nothing to remember. You just need to remember one, then you will know the other. If it's minus, if the power here is a minus sign, it will just reflect.
Okay.
Yeah. So there is another one, which is the difference between 2 to the power of 3x and minus 2 to the power of 3x. Because there's a minus sign here, right? All your y values will become negative. Okay? Okay, what do I mean by this? Because considering y to be equals as 2 to the power of 3x and y equals to 2 to the power of minus 3x. Sorry. What am I writing? Minus 2 to the power of 3x. This one doesn't have a negative. This one has a negative. Means all your y values will become negative values. So your graph should look like that. Where this thing here is minus 1. It will flip. So for this one, it's like reflect about the x-axis.
Yeah.
Okay?
Okay.
Yeah. Can So with that said, right, that's all for exponential graph. We will go into this question to understand how to sketch it. Any questions so far?
No.
Okay. We'll do this together, don't worry. We'll do this together. Okay. For the first graph here, 2 to the power x plus 3. Okay. In order to draw 2 to the power x plus 3, it is better that we draw 2 to the power x first. Then we draw 2 to the power x plus 3. Okay. So one thing we know for sure, 2 to the power x will look like that. Correct? Yeah, because just now I already mentioned, if it's 2 to the power of kx. If k is positive, then it will look like that. If k is negative, it will look the other way. Sorry. It will still cut at 1. Okay. So over here, it will cut at 1. Okay. With the, over here, not to mention, I have to mention, not to mention. Over here, there is a horizontal asymptote. The reason why this curves like that is because over here, right, there is a horizontal asymptote.
Yeah.
You know that, right? And the horizontal asymptote, right, will take the equation of y equals to 0.
Mm.
Okay? So this is the graph of y equals to 2 to the power of x. If now I want to draw the graph of y equals to 2x plus 3, what's going to happen to this graph? The whole graph will shift. Will shift what?
It will shift up by 3.
Correct. The whole thing will shift up by 3 units, including the horizontal asymptote. Okay? So now I'm going to erase this. So horizontal asymptote, I will use a purple line to denote because it's hard to draw dotted. So the horizontal asymptote becomes y equals to 3 now because you plus 3. Then your new graph will look the same shape, curving up. But now, this point here will be 1 plus 3, which is 4. And here you go, you have your y equals to 2 to the power of x plus 3. Label, label, label. Full marks. Okay, so from here we have to state. So this is step 1, right? Step 2 is state the domain and range for each function. What is domain? Okay, not sure if you still remember. Domain means, right, it is the interval of x where the graph exists. Okay, for range, it's basically the interval of y where graph exists again. Okay, so what is the interval of x where this graph exists? Like this whole graph. What's the interval of x? It will keep going to the left and keep going to the right, right? Correct? Hello?
Yeah.
Yeah. So the domain of this graph, okay, it will be equals to all real numbers. Alternatively, you can also denote it as negative infinity to positive infinity. Okay. Then what is the range? The range of this graph will be the range interval of y where the graph exists, which is from this point all the way up. Okay, so in this case, we will have to use the bracket notation to define it. Okay, be very careful, because we are not including the 3 over here. The 3, y equals to 3 here is the horizontal asymptote. So it will go very close, really very, very close to the horizontal asymptote, but it will not touch it. So we cannot include 3 because it's very close to 3. We have to exclude 3, comma, all the way up, which goes to positive infinity.
Yeah.
Can?
Can.
Okay. I hope this is very clear. Okay. The next graph. Hx 2 to the power of minus x. So just now I mentioned, for 2 to the power of kx, if k is negative, it will flip about the what axis?
If k is negative.
If k is negative,
Y-axis.
Y-axis, yes. Yes. I mean, it is not very smooth because of like this part, But still, I think it's commendable. Okay, anyway. It will always cut at 1, okay? Okay, if you don't know why you always cut at 1, you can just solve it for x equals 0. Right? You want to find a y-intercept, right? Y-intercept means x equals 0. So when x is equals to 0, since y is equals to 2 to the power minus x, so y will be equals to 2 to the power of 0, which is 1. Okay?
Yeah.
Yeah. Okay, so this is the graph already, 2 to the power of minus x. Okay? There's no need to find x-intercept because there's no x-intercept, because there's a horizontal asymptote once again at y equals 0. So over here, what is the domain? Anissa, what's the domain? Domain is the interval of x where the graph exists, right?
Negative infinity to positive infinity.
Very nice. Or alternatively, you can write equals to the Greek, this symbol r, which means all real values of x. Okay, what's the range then?
More than 0.
Y more than 0, right? Does it include 0?
No.
No, very good. So we'll write it as 0 to infinity. We exclude both by indicating the round bracket. Because if you want to include, you have to show square bracket.
Wait, why cannot include infinity?
It's infinity. Can you reach infinity?
Oh, no. Okay.
Right?
Yeah.
Like, I tell you, if we damn sadistic for someone, can you please count to infinity?
Quit the job.
Huh? What?
Quit the job.
Yeah, quit, man. I'll quit. It's impossible. You cannot count to infinity. That's why you cannot include infinity. Okay. Okay. So I think you grasp the concept of domain and range already, and you understood that for 2 to the power of x and 2 to the power of minus x, the difference is that they reflect about the y-axis.
Yep.
Yeah, it's important to know the shape. Okay, next up, minus 2 to the power of x. Okay, so for minus 2 to the power of x, how should we draw this? Okay, minus 2 to the power of x. Remember, what's the relationship between minus 2 to the power of x and 2 to the power of x? What's the relationship?
Reflector along the x-axis.
Yes, correct. So the graph will look like that. power. And this intercept will be?
1.
It's below the x-axis.
Oh, -1.
Yes. -1. Okay. So what's the domain?
Negative infinity to positive infinity.
Yes, correct. What's the range?
Less than -1.
What?
Less than -1.
But what about this portion here?
To infinity. To negative infinity.
Yeah, but what about this portion here? You say less than -1, right? Less than -1 is only from here.
Huh?
You said that the range is less than -1, right?
Yeah.
Less than -1 means it's only starting from here. Means you are saying that the range is from here to here.
Oh, sorry, less than 0.
Less than 0. Yes. So, or you can write it in bracket notation, which is from negative infinity to 0.
Okay.
Can
Yeah, okay.
Okay, the next graph. Sorry, give me 1 minute. I want to turn on the light. Okay, I'm back. Okay. So, 2 to the power of x minus 4. Okay, this is something new already. This is something new. Okay, we know that 2 to the power of x is drawn like that, right? With here being 1. Okay. So from 2 to the power of x, right, to 2 to the power of x minus 4, right? Something changed, right? Because x was being replaced with x minus 4.
Yeah.
Correct? Okay. I have my own way of doing this kind of transformation. Okay. It may be very different from what your teacher is going to teach you. Okay. So remember, when you are replacing, okay, you gotta ask yourself, what are you replacing? When you replace x with x minus 4, right? It looks like we are moving the x, we're moving the graph to the left, right? Like negative forward, right? X minus 4. It looks like we are supposed to move this graph like to the left. But it should be like over here instead. Right? By 4 units.
Yeah.
Makes sense. But no. When you want to for x, right, it's always reverse. When you're replacing x with x minus 4, right, you're moving to the right by 4 units. It's always reverse. Just remember that.
Okay.
Can whenever you see, like, for instance, I have like say 4x squared as compared to 4x minus 2 squared. Okay, you can plot this graph on your or rather x squared versus x minus 2 squared. You plot the graph on GC. One thing we know for sure that x squared looks like that. This is x squared.
Yeah.
Yeah. But x minus 2 square will be, we thought, most people will think that, oh, x minus 2, so I shift the graph to the left by 2 units. But no, if you plot your graph, right, you'll realize that the graph will look like that. And this part here, right, is 2. Okay?
So where do you draw it out?
Yeah, I did. Over here.
Okay.
Yeah. You realize that actually when you replace x with x minus 2, right, the graph shift to the right. It's always opposite, just remember.
Okay.
Yeah. Whereas for values affecting the y, right, like x squared to x squared plus 2, right, this is still the same. We are still shifting the graph up, but upwards by 2. Okay, please do not shift the graph down for this one. Okay, it's only when you deal with the x you have to shift in the opposite manner. Can?
Wait, sorry, I don't what?
Okay. It's only that when you shift the graph in when you want to shift the graph left and right, right? When you're dealing with the x, right, over here. Sorry. When you're dealing with the x over here, right? Okay. Then you have to shift it in the opposite manner.
Okay.
Yeah, but when you're dealing with the y, right, you see x squared and x squared plus 2, right? This is just shifting up and down. So you still shift as per normal. Okay?
Okay.
Okay. So now how do we draw the graph of 2 to the power of x minus 4? So one thing we know for sure is that 2 to the power of x minus 4, right, compared to 2 to the power of x, right, is that we are shifting the graph 4 units to the right.
Yeah.
Yeah. But the thing is, we still need to be able, the graph will still look like that. Sorry. Oh my God. The graph will still look like that. It's just that this point here is different now. Okay? How to find that point? Will be when x is equals to 0, y will be equals to 2 to the power of 0 minus 4, which is equals to 2 to the power of minus 4, which is equals to 1 over 16. So this point here will become 1 over 16 instead.
Yeah.
Can Okay. One last one, then we can call it a day. Over here. 3 times 2 to the power of x. Okay. For 3 times 2 to the power of x, it's basically all the y values multiplied by 3. Originally, this was 1, right? The y-intercept is 1, right?
Yeah.
Yeah. And we also know that the horizontal asymptote is y equals 0.
Yeah.
Okay. So when is times 3 means all the y values will times 3. Okay. Which means this this y-intercept here will become 3 because 1 times 3 is 3.
Okay.
Yeah, but the horizontal asymptote, does it shift?
No.
No, it will still remain as y equals 0.
Yeah.
Can
Yeah.
Okay, so over here, what we learned for the past 15 to 18 minutes, right, is basically learning about exponential graph, which is very important in this chapter. Okay, but of course your school, I think your school already touched on this, right?
Oh, they didn't teach us how to sketch. With the just the
Sorry again.
like I mixed it up with another graph, like rational functions.
Sorry, are you seeing the PDF document or?
No, as in like the one that I told you my school taught me the 三毛经 one. Yeah, that one's about rational functions, not exponential.
Oh, okay. But anyway, the next thing you're going to learn is exponential functions. It's just now when I was drawing, right? Am I drawing on the whiteboard or am I drawing on the PDF document?
PDF.
Huh, serious ah?
Yeah.
Oh my god. No wonder you cannot see. I thought I was sharing the whiteboard.
No, as in I can see your drawing.
Yeah, but I meant to draw on the white. Oh my god. I'm so sorry.
Yeah, it's okay. As in, I could still see, just that it took a bit longer because I didn't know where you like the cursor was.
It was supposed to be this. You're supposed to be on this background.
Oh, okay.
I'm so sorry. But you understood, right?
Yeah, understand.
Okay. Oh my god, I'm so sorry. This is the downside of online tuition. Okay, so that was graph transformation, and over here, all these questions are problem sums related to exponential graphs. Okay, maybe later I can send you a few of these examples, then you can go and try, and then you can send to me.
Yeah, okay.
Can?
Okay.
Yeah, if not, you can go have a great dinner.
Okay.
Okay, I'll send the recording later.
Okay.
Okay, bye-bye.